Today we are going to do the second conic section, which is the parabola. The parabola is used for two main applications, and I'll talk about them as we go through this presentation, but just as a high level, first, one application of the parabola is physics. If you throw an object in a gravitational field, this is the equation. X equals x0 plus v0t plus 1/2 gt squared. That's gravity. T is time. v0 is initial velocity. x0 is initial position. This is parabolic. T is what the t squared is. And therefore, when you throw something through a gravitational field, it looks parabolic. It looks like a parabola. The second application is what I call focusing devices. Lenses, for example, in your eye, you actually eyeball the lens of your eye. Our camera lenses are parabolic. And other focusing devices such as satellite dishes, which you probably have in your house to get TV, and flashlights is also a focusing device. Those are all use the geometric shape of parabolas. Okay, so this is the high-level applications. I'm going to start with the definition of a parabola, and it'll give some of the idea of why it's a focusing device as well. And again, just like when we were doing circles, these are going to be equations, not just geometric figures. So a parabola is a series of points, in other words, a graph, that are equidistant from a focus and what is called a directrix. It's D-I-R-E-C-T-R-I-X. I'm going to show you this on a picture rather than just try to define what a directrix is, for example, or a focus. If we've got a parabola, it looks like this. Parabolas look like this, basically. If that were upside down, you can imagine that would be, for example, the motion of throwing something through the air. It would come, and it would be the reversed, so it would be going up, down, and come down. This one I'm drawing opened up. So this is right here, this point right here is called the vertex of the parabola. It is the low or high point, depending on the orientation of the parabola. A couple other things. The directrix is actually a line. And if it's in this case, a parabola that's opening up, down, that's called a vertical parabola. Then it is an equation of a horizontal line, which is y equals something. We'll get to the something in a moment. The focus is a point inside the parabola. See if I get opening up. And again, what this says is the points are defined such that the distance from, if I have a point here, the distance from here to the focus is the same as the distance here from the directrix, which would be straight down. So in other words, that distance is the same as that distance. And that's true for every point on the parabola. That's what defines the parabola. A couple other definitions. This line that goes through and splits the parabola in half is called the axis of symmetry. Now I'm going to give you equations for every element on here in a moment. So again, the parabola definition itself is all the points that are equidistant from a focus, which is a point, to a directrix, which is a line. The vertex is the low point in the parabola if it's this way, or a high point if it's flipped upside down. The focus, we'll talk about that in a second, is a point where everything focuses in the parabola itself. The axis of symmetry splits the parabola in half. Okay, so what makes the parabola interesting from a focal or a focusing device perspective? I'm going to erase some of this other stuff off of here to show you. Just going to draw a simple one here where we've got the focus right here. Okay, what a parabola does is if light or sound or something comes towards it, directly towards it, think of like a satellite dish, for example, every point where it hits the parabola of this will come back and hit the focus. No matter where it's coming in, again, straight on. Let's come this way. This one will go that way. It'll all end up at here. It'll focus it on that point, which is why it's called the focus. Now, why is that useful? Think about what a satellite dish does. You're getting signal from DirecTV. Say it's coming into your dish on your house. It all comes in to a given, or it hits it along the dish, and it bounces off to your center point. Now the center point is floating above the vertex, so what you do in the case of a satellite dish is you actually put a metal tube in the middle, and you go out and look at your satellite dish, you'll see this. There'll be a little device in the middle, and it'll have a little sensor at the top, which will gather the signal from the satellite, which then goes into your house, into your satellite set-top box or cable set-top box, and it translates it into a television signal. Same idea is true with a lens for an eye, except it's reversed a bit. So let me draw a lens of an eye. I'm actually going to draw this one sideways. It actually has two parabolas, but I'm just going to make it a little simpler. Make it more like your eyeglasses. So in other words, this is your lens. Here's your actual eye out here. This is a hole. The pupil's here. It comes into your lens. Light comes again this way. Notice this is parabola. This time the parabola is facing this way. Every point that comes in to your lens gets reflected down to a point in the back of your eye by the parabolic focusing device of your lens. And it hits the back of your eye. This point that hits the back of your eye is called the retina. And then that goes and translates to an optic nerve to your brain, which translates that stuff coming in, light, into a picture and an image which you can see. This is also the basic idea of how a camera lens works, essentially the same way as your eyeball. Okay, so that's why it's useful. Now we're going to go back and do a little bit of mathematics. I'm going to write an equation for a parabola, which is y equals a x minus h squared plus k. This is an equation for a vertical parabola, like the first drawing I drew, like this, or this. In other words, it's opening up or it's opening down. We'll do horizontal in a minute. But that's the equation for a vertical parabola. In it, h comma k is the vertex. Notice again it's x minus h, so that'll be important how you choose the h, just like the circle it was. A is the, basically determines the focal length and the focus, and it is called the dilation constant. If A is, it can be positive or negative. If A is bigger than 0, it opens up. And if A is less than 0, it opens down. The axis of symmetry, which is one of the other terms I gave you on that first picture, is given by the equation x equals h. H is the same number as the h value, the x value in your vertex. Okay, so here's some of the terms I had on that first picture. Axis of symmetry, there's the equation for vertex. This A determines your dilation. It'll actually change the shape of the parabola. And I haven't given you the other two elements of it. Let me give you all the equations in one spot, and then we'll calculate them. We have the focus. The focus is actually determined by A, and we're going to call the focus length C, actually. And it is 1 over 4 times A. So in other words, if you have like 1 in front of your parabola, your focus, what's called the focal length, is 1/4. If you want to get the focal point, you just go to your vertex and go up by the focal length. So let me draw that picture again. I didn't put the focal length on it before, unfortunately. There's the vertex right there that I've drawn. And the focal point, or the focus, is right here. This distance here is called the focal length. With some of you are photographers probably recognize that name. Focal length is simply the distance from the vertex to the focus. So the focus length is just 1/4. It's 1 over 4A is totally determined by the number in front of there. More commonly, actually, you are trying to calculate A. In other words, you want to shape the lens based on what you want the focus to be. You can just flip those two by proportion rules, and A is 1 over 4C. The directrix is equidistant on the other side, and it's y equals, and it'll be k minus c, although you see in a moment we'll hardly ever use this equation. We'll just do it from a graph. Okay, so there's your equations. Here's the basic equation for the parabola, here's the equation for the vertex, equation for dilation, axis of symmetry, the directrix, and the focal, should be focal length, really not focus length, focal length, which will determine the focus location ultimately. Okay, to make this a little clearer, I'm going to actually do a graph of one and do all of this stuff. I'm going to pull up my board here so that we have something to graph on. And I'm going to start with the equation y equals x minus 3 squared plus 2. Okay, so first I'm going to go through the various pieces of this, but before I do that, I actually am going to graph, actually I'm going to start with that before I do that one. You're right, it's a second. I'm going to start with y equals x squared, and then I'm going to do y equals x minus 3 squared plus 2. The reason I'm doing this first is I just want to show you how you draw a basic parabola before you actually move it around. So y equals x squared, I can do a simple table. I'll plug in some x's. I'm going to plug in -2, -1, 0, 1, and 2. Just 5 points, and that's how I have you plot most of the parabolas. Y is just x squared. So if I just square -2, I get 4. If I square -1, I get 1. If I square 0, I get 0. If I square 1, I get 1. And if I square 2, I get 4. So that gives me an equation that looks like this. There's 0, 0, -1, 1, -2, 4, 1, 1, 2, 4. Obviously I can keep going. And just connect the dots, and there's my parabola shape. What I want you to think about as you draw these, to make it a little simpler, is if you have a parabola, start from the origin. The first point is going to be over 1, up 1, over 1, up 1 to 1, 1. The second point is going to be from the origin over 2, up 4. 1, 2, 1, 2, 3, 4. So think about that when you draw the base parabola every time. That's only true if there's a 1 in front of here, like there's a is 1. When you do 2, things like that, dilations, if that's 2 or 3 or whatever, that'll change the shape. Anyway, this is the basic parabola. It'll always be over 1, up 1, over 2, up 4 on both sides. Over 1, up 1, over 2, up 4. Okay, so now I'm going to graph that one and also put all the information on it. Okay, so let's start with the vertex. The vertex you just take right off the equation. It is 3, 2. And again, just like in the circle, you got to be really careful. This one you change the sign of. Remember, it's y equals x minus h squared, so the h part is 3. The k is plus k, so you don't change the sign of that. So it's just 3, 2. So I'm going to plot that point first. There we go. There's my vertex. Okay, now I do the base parabola. It's a 1 in the front, so I just go over 1, up 1, over 2, up 4, over left 1, up 1, left 2, up 4, and there is my basic parabola. Okay. Now I'm going to calculate some of those other things. I'm going to calculate the focal length. That, remember, is just c equals 1 over 4a. A is 1 in this case. Don't really write it, but that's 1x squared. And that's 1x minus 3 squared. So it's just 1 over 4 times 1, or 1/4. So what does that mean where the focus is? It is 1/4 up the axis of symmetry. Right there. So close you can even barely do it. Most parabolas don't look like that as a result. Like lenses are very flat, satellite lenses are very flat, because you don't want the focal point to be that close typically. Otherwise you can't collect a lot of the radio signal. It's too narrow. Okay, but anyway, that helps you. So now I can get my point. And the way I get my focal point, or focus, is I just, to get this point, I'm at x is 3. And I just take 1, 2, and 1/4. So it's just 1/4 up from my vertex. There's my focus, there's my vertex. If I want my directrix, which is, remember, is a line, it is y equals, and it's the line that's 1/4 below the vertex. Below is the wrong term, really. It's on the other side of the open part. Because we'll have some in a moment that are upside down. Okay, so that equals just this point here is what the y value is. It's 1 3/4, or you could say it's 2 minus 1/4, which is what the equation actually said. or 1 3/4. If you want to write that as 7/4, that's fine as well. Okay, other things we have the axis of symmetry. That is equal to x equals h. H in this case is 3. It's this line right here. X equals 3. It's the same line that the focus is on. There we go. So that's the way you do it. First, graph your parabola, find your vertex, put it in the right spot, find your focal length, go up that distance to get your focus, go down that distance to get the directrix. Remember, the focus is a point, the directrix is a line, and then for axis of symmetry, you just draw a line down the middle of your parabola, and it's x equals whatever the first coordinate in the vertex is, which is h, in this case 3. Okay, let's do another one. Do a little more complex one. This time I'm going to put a 2 in the front. Okay, so start again with what is the vertex. That doesn't, 2 doesn't affect that. It's still just -1, -3. -1, -3. Okay, what does the 2 do? I'm actually going to do an extra little table here to show that. If I have x and 2x squared, we have to plus 1 for a moment. This is y. Let's just say I was going y from y equals 2x squared, and then I'll move it. Again, I put -2, -1, 0, 1, 2. If I put 0 in, I still get 0. If I put 1 in, or -1, I get 1 times 2, or 2. If I get 2 in, or -2, I put 2 in, I get 2 squared, which is 4 times 2, or 8. So what the 2 does is it basically stretches out all my y values. Instead of going over 1 up 1, 0, 0 to 1, 2, 1, 1, I go 0, 0, 1, 2. So 1 becomes 2. I stretched it out. And the one when I went over 2 up 4 now becomes over 2 up 8. So 2, 4, 6, and 8. And it's symmetric again, so it's over here. And there's my graph. So again, what does the 2 do? It dilates the parabola. In this case, it makes it thinner. It stretches it out this way. And every point, y values were 0, 1, and 4, now become 0, 2, and 8. And that's how it stretches it out. If you want something to be flatter, you actually have to have a fractional number in front, like a half or a quarter. And that's actually what most real parabolas, like satellite dishes, things look like that. They'll have like an eighth in the front. Okay, so anyway, there's the vertex. I plotted that. Now I'm going to find the focal length. Focal length is 1 over c. Remember, it's 1 over 4a. A is 2, or 1/8. It's smaller than it was before, so that means it's even closer. Really hard to even draw it accurately. So the focus is again -1. That doesn't change. It's on this line, and it goes 1, 2, 3, but then it's an eighth above it. So it's -2 and 7/8, or in other words, -3 plus an eighth, which gives you -2 and 7/8. The directrix, again, is y equals, and it's below it, so it's 1, 2, 3, and an eighth, and it's -3 and an eighth. So again, the way you find the focus and the directrix is just draw the vertex, go an eighth up, an eighth down, the focal length up, the focal length down. The focus is inside, the focal length is outside, or the directrix is outside, and then just use a little arithmetic to find their lengths, or their equations. And then finally we have the axis of symmetry, A of S, which is x equals h, which in this case is -1. And that's it. Okay, I'm going to have you guys try a couple. Okay, y, let's try this one. Y equals -x squared plus 2. Okay, once you try that one, I want to draw it and do as many of the things as you can do. It's a little trickier because it's got a negative sign in there. That just means it's upside down. Okay, now I'll pause there and try it. Okay, if you're back, let's start with the vertex before we do anything. The vertex is simply, there's nothing there. It's not x minus h, it's just x squared. So the vertex is actually 0, 2. So it's right there. What does the negative sign do? It doesn't just go over 1 up 2, over 2 up 4. The negative sign actually means it goes over 1 down 1, over 2 down 4. It basically reflects it. And otherwise there's just 1 in the front, so just like this. Like so. Then we find the focal length, which is just like the ones we had before. It is -1 1/4. The actual length is 1/4. You can't have negative lengths, really. But if you put in those equations I gave you, you want to use -1/4. And that means the directrix is 1/4 above this, and the focus is 1/4 inside. So the focus, and again, there's equations for it, but it's easier just to say the focus has to be inside the parabola. The directrix has to be outside, and it's a line, and then just count. Use some simple arithmetic. So in this case, the focus is 1, 2 less 1/4, or 1 3/4, and it's on the x-axis, so it's 0, 1 3/4. And then the directrix is 2 1/4, and that's y equals. There we go. Okay, you can also get equations from, this is the last thing we'll do on this video, and I'll do horizontal parabolas separately. You can also get equations from the graphs. So let me do that. So let's just draw a parabola over here. And say, what is that graph? What is that equation, rather, for that graph? Okay, so you just basically reverse what we were doing before. You find the vertex first, which you may not be able to see on this, but it's 1, 2, 3, 4, 5, 6, 4. So my vertex is 6, 4. So that means my parabola equation is y equals x minus 6 squared plus 4. And then I just have to have an a in there, which I have to remember what that is. And now I look at the shape of the parabola. If it goes over 1 up 1, it's just 1. If it's over 2 up 4, or it's up, it's just, again, 1. If it's over 1 up 2, over 2 up 8, then it's 2. If it's over 1 up 3, then it's 3. If it's over 1 up 1/2, then it's 1/2. In this case, it's just 1. So there's my equation. And then I can get things like the focal length, which is just going to be 1/4, and find the focal point, which would be 6, 4 1/4. Directrix 6, 3, or y equals 3 and 7, or 3/4, 3 and 3/4. So you can get all that from there. Okay, let you guys try one. If you can't see that, that's point -4, -2. Hopefully you can see this well enough to actually come up with an equation. Okay. Pause there, write down the equation, and come back. Okay, so again, start with the vertex. That is -4, -2. And then that means the equation is y equals a, x plus 4 squared minus 2. I just have to find a. In this case, it's negative because it's upside down. And I'm going over 1 down 2, over 2 down 8. So it's actually -2. And that allows me to find the focal length, which will be 1/8 again, and find the focus, which would be -4, -2 and 1/8. Directrix, y equals -1 and 7/8. And axis of symmetry again, x equals -4. So you can find all that once you've graphed it. Okay, we're going to pause there, and I think I'm going to do the horizontal parabolas on a different video. So just stop the video there, and we will come back to the other one to see it in 2 chunks. Thanks.